Alright, let's solve a couple of some very simple problems based on the International System of Units, SI units, that we just saw earlier. Right? So let's use these powers of 10 and see how we can apply them in a very simple problem. Assessment problem 1.1 from the textbook. And the problem says, let's assume the telephone signal travels through a cable at 2/3 the speed of light. So given that the velocity is 2/3 the speed of light, and the speed of light is a very well-known quantity, 3 into 10 to the 8 meters per second. Okay, and further the problem goes on, how long does it take the signal to get from New York to Miami if the distance is 1100 miles, right? And that is not in our standard SI unit, so we are going to have to convert that to meters or kilometers. Okay, and then we are asked to find out the unknown quantity here is time. Okay, that's what how long does it take for the signal to get from point A to point B. Okay, so let's see if we can solve this problem, some very simple problem. The first thing I'm going to do is to use the knowledge that 1 mile is 1.6 kilometers. Okay, so 1.6 kilometers per mile. Okay, and then that's going to give me roughly around 1770 kilometer. Okay, that is the distance that the signal has to travel, and time is that guy. And we know from physics that distance equals to speed into time, therefore time is distance by speed. So let's divide these two quantities. Okay, distance is 1700, that's distance, and then of course speed is this quantity, right? Speed is all of that quantity, which comes out to be 2 into 10 to the 8 meters per second. Okay, so that's a very straightforward problem. Do the math, and so this kind of problem resolves into a very simple math problem. 1700 kilometer, right? Kilometer is 10 to the 3 meter divided by the speed was 2 into 10 to the 8 meters per second. Okay, so meters per second. Now you can do the math, and this will come out to be, the time will come out to be 8.85 into 10 to the negative 3 seconds, or 8.85 millisecond. Okay, that's what we are after. We are asked to find the time it takes, right? And the time we found out to be 8.85 milliseconds. Okay, now that's assessment problem 1.1. Let's do another problem. This is fun. Very simple problem, assessment problem 1.2. It seems how many dollars per millisecond. So we are trying to find a quantity that is dollar per millisecond. That's the unknown. Would the federal government have to collect if they are trying to retire a deficit? Okay, they're trying to defy. So given is deficit is $100 billion. Okay, that sounds like the magnitude of the problem that the governments face. Now, the timeline, we are looking at 1 year, right? So that is how long the government wants to recover this money in. Okay, so let us see if we can convert all of this. Billion is again 10 to the 9. So what we have is 100 into 10 to the power of $9, and we are trying to recover that within 1 year. Okay, the only conversion that I'm going to do here is to convert from year into seconds, right? That is our favorite SI unit. So all I have to do is 1 year has 365 days per year. Okay, and in each day there are 24 hours per day. Okay, so 24 hours per day, and then there are 60 minutes per hour, and then there are 60 seconds per minute. If you write it in this fashion, then what happens is these years cancel out, the units cancel out, number of days cancel out, right? Number of hours cancel out, minutes cancel out, and what you will be left with is a quantity 365. Of course, there is 1 year, 365 into 24 into 60 into 60, all of that in seconds. Okay, so that's the amount of time, and we are after a quantity that is dollar per millisecond. Let's see, we are going to divide the dollar quantity, which is $100 billion. That's this guy. Okay, $100 billion, 100 billion by how much ever this comes out to be, 365 into 24 into 60 into 60 dollars per second. Okay, so the units are dollars per second. So that comes out to be some and you can plug this into the calculator, and this comes out to be 3170, right? 3170 dollars per second. Okay, but we are expecting the answer in dollars per millisecond. Okay, this is dollars per second. That's the quantity. So simply we know that 3170 in the numerator stays the same because it's still in dollars. The denominator, I know 1 second, I can write it as 1000 millisecond. Therefore, we have a solution that is $3.17 per millisecond. That's what we are after, right? That's the answer we are after, $3.17 per millisecond. So let me write it here, $3.17 per millisecond. Okay, let me make sure I go back to the original problem and make sure that I have the units mentioned there.